For years we've stared at Jupiter and told ourselves we understood it. A gas giant, a massive ball of storms and hydrogen, a relic of the early solar system. But what if that story was never the full picture? What if Jupiter wasn't just a chaotic world of weather systems and volcanic moons, but something far more calculated and perhaps even aware? After nearly a decade of orbiting this planetary giant, NASA's Juno spacecraft is approaching its final breath. But before it descends into the swirling abyss, Juno has sent back something it never expected to find: images and data that defy the very rules of planetary science. What it captured was not just beauty, but behavior, a set of patterns, pulses, and reactions that suggest Jupiter is not what we were told and may never have been just a planet at all. Juno's final chapters began with a descent into the chaos of Io, a moon so volatile it appears to be alive. Juno's close flybys between 2023 and 2024 brought it within just 1,500 kilometers of the surface, where it captured surreal images of lava fountains erupting dozens of kilometers into the vacuum of space. But what made these images so disturbing wasn't just the violence, it was the order within it. Several eruptions were recorded to happen in near-synchronized pulses, almost as if responding to some internal clock. Even more bizarre, Juno's instruments registered a magnetic fluctuation just as it passed over the massive Loki-Patera lava lake. This wasn't a minor deviation, it was a deliberate oscillation, as if something beneath Io's surface had reacted to the spacecraft's presence. The data suggested coordinated thermal activity across volcanoes, separated by hundreds of kilometers, which shouldn't be possible under any known tidal heating models. Could it be that Io isn't just responding to gravitational stress, but to something more? Juno's mission was never just about the moons. It was about peeling back Jupiter's dense, colorful mask. As it dove into the planet's north polar region, its microwave radiometer revealed a disturbing contradiction. While visible and infrared images showed a stable, well-formed cyclone at the pole, the microwave data showed nothing. The center of the storm, the very eye, was hollow in terms of deep radiation signature. It was as if the storm structure existed only on the surface, with no real depth beneath it. Other nearby cyclones showed intense subsurface energy, but not this one. It was hollow, silent, invisible to the instruments that peer beneath the clouds. One scientist unofficially referred to it as the mask, a manufactured weather event perfectly circular, completely calm at the center, and devoid of the chaos that defined every other Jovian storm. The implication that something or someone may have shaped that vortex for a purpose. While passing through Jupiter's chaotic radiation belts, Juno's instruments unexpectedly captured anomalous thermal activity from one of the smallest moons in the Jovian system, Amelia. Only 84 kilometers wide and shaped like a lopsided potato, Amelia was never expected to be of any major interest. But during Juno's 59th perijove, the probe recorded something strange. Amelia was glowing in infrared, and not just passively. It pulsed, a rhythmic, repeating thermal emission synchronized with Juno's flyby window. The pulses faded when the probe moved beyond direct line of sight. Initially attributed to tidal friction or induced electric currents from Jupiter's magnetic field, the emissions became more troubling when analysts discovered a perfect alignment between the pulses and a previously undetected magnetic wave coming from Jupiter's equator. It was as if Amelia had received a signal and then responded. Was it a coincidence, or had this tiny moon been acting as a node in a larger planetary system of communication? Though Saturn is famous for its rings, Jupiter has a system of faint, dusty rings of its own. But during Juno's recent close passes, something shifted. The spacecraft sensors recorded anomalous density readings in the outer edges of these rings' pockets, of material that moved in defiance of gravitational models. Instead of rotating smoothly, small clusters of particles accelerated against their orbital path, briefly shifting out of alignment before returning to equilibrium. These distortions were subtle but repeated. Most surprisingly, they always occurred when Juno crossed through a specific magnetic corridor emanating from Jupiter's atmosphere. Scientists have no natural explanation for this. Jupiter's rings are too thin to support this kind of energetic reaction. One theory suggested charged plasma particles influencing dust behavior, but the patterns were too precise. One physicist noted, "They move like they're being told when to move." If true, then Jupiter's rings aren't just debris. They're an instrument, one we've only just started to hear. For centuries, the Great Red Spot has mesmerized astronomers. A colossal storm twice the size of Earth, spinning violently for over 350 years. But Juno's high-resolution microwave and infrared data from its 59th and 62nd perigeo showed something previously hidden. The spot is evolving in impossible ways. Deep inside, the temperature gradients fluctuate irregularly, sometimes increasing, while surface winds remain stable. In one pass, Juno detected a sudden thermal pulse emerging from the storm's core, a 20% spike in temperature over less than a minute. Even more unsettling was the discovery that the red spot is not a closed system. Juno's sensors caught a filament of hot gas emerging from the spot and traveling east like a tendril before vanishing into the surrounding cloud bands. Weather doesn't behave this way. It doesn't send out streams unless the storm isn't just a storm. Some researchers now speculate that the Great Red Spot may be tapping into internal energy sources, possibly deep within Jupiter's core. Others are more cautious, calling it a planetary pressure valve. But one thing is becoming clear. This storm isn't dying. It's stabilizing, and it may be part of a system too vast and too ancient for us to comprehend. Jupiter's striped cloud bands are driven by powerful jet streams, bands of atmosphere that whip around the planet at over 300 miles per hour. But Juno's instruments began to detect strange behavior in the jet stream regions during the 61st to 66th orbits. In the folded filamentary region of the northern hemisphere, the jet streams began to break down, forming chaotic, ever-shifting patterns. Beautiful, yes, but buried in that chaos was structure. The cloud movements, when analyzed in sequential image data, revealed repeating geometries, hexagons, spirals, mirrored curves like weather systems tracing fractals. Using motion mapping algorithms, NASA analysts identified motion loops that completed every 6.2 hours, Jupiter's rotation period. But some loops completed in 3.1 hours, half the cycle. Some even quartered it, forming recurring quadrants like gears in a machine. The data didn't just suggest movement, it suggested mechanical rhythm, a planetary heartbeat. Was it natural turbulence in a dense atmosphere, or something more computational? Juno was seeing storms, yes, but storms that knew their own timing. One of Juno's final objectives was to determine Jupiter's internal structure, particularly its water content. Using microwave radiometry, it mapped the distribution of hydrogen and oxygen throughout the planet's upper and middle atmosphere. But something didn't add up. While water was expected near the equator, Juno found unexpectedly low concentrations. At the core, it should have been rich with ice-derived heavy elements. Instead, it was sparse. This discrepancy led scientists to consider an unsettling possibility: Jupiter's water is being displaced. But to where? In a 2024 data dump, Juno recorded massive thermal readings in the lower atmosphere beneath the equatorial zone, too deep to be explained by solar heating and too diffuse to be volcanic. The signature resembled warm liquid beneath a dense gaseous shell, a fluid ocean within a gas giant. Such a structure defies current planetary formation models. But more alarming was the vertical movement columns of material rising and falling like convection or respiration. Is there something moving inside Jupiter's depths, feeding from within and exhaling outwards through storms? Juno's mission is scheduled to end in September 2025, with the probe making its 77th and final dive before disintegrating in Jupiter's upper atmosphere. But during its most recent orbits, something strange happened. On its 69th pass, Juno's communication systems experienced a 3-second blackout, not due to solar interference, not due to hardware failure, but a total data halt. When the signal resumed, no fault was detected, but the time window precisely 3.141 seconds was noted, a number eerily close to pi. A cosmic coincidence, maybe. But during the blackout window, the probe was over a zone of Jupiter's atmosphere where magnetic resonance had previously spiked a convergence point. NASA called it a minor telemetry delay. Internally, engineers were less sure. One document included a handwritten note. The planet blinked. Since then, mission protocol has changed. All subsequent flybys are being routed farther from that coordinate. Is Juno being protected or is it being kept away? The probe may be nearing its end, but perhaps Jupiter has already decided what it will allow us to see. Juno was never meant to survive this long. It wasn't designed to uncover mysteries that challenge the foundations of planetary science. It was built to observe, to measure, to send data. But Jupiter had other plans. What Juno uncovered wasn't just weather or magnetism or volcanic fury. It found rhythm, pattern, echoes of coordination, whispers of design. From moons that pulse in time with the planet's heartbeat to storms that vanish under microwave eyes.